Okay, here's your third example for implicit differentiation. We have 4 terms, 1, 2, 3, 4. However, this one is different because one of your terms, the x squared y squared, is now going to require you to go back and use product rule when you do the derivative. All right, so remember product rule. I had you label them A times B. So A is your x squared, B is your y squared, and you're going to use A prime B plus A B prime for this one term right here. All right, so these get a little bit longer, a little bit more complicated. Just stay nice and neat and organized. All right, so let's go through and take the derivative of each term with respect to x. So the derivative of x to the 4th is going to be 4x to the 3rd dx dx. All right, bring down the plus sign. Now, for this term right here, we have to apply our product rule. So we have to do A prime. So the derivative of x squared is going to be 2x times b y squared. But we just took the derivative of x with respect to x. So this term is dx dx. Bring down your plus sign. Now I have to do A times B prime. So our A value is x squared, and the derivative of y squared is going to be 2y to the 1st, but we took the derivative of y with respect to x, so this term has dy dx. So this right here is just the derivative of x squared, y squared. Keep going. Bring down your minus sign. The derivative of y squared is 2y dy dx. And the derivative of any constant is 0. All right, so let's clean this up. We have dx dx here, so we're going to cross that out. Dx dx here, we're going to cross that out. And I'm just going to rewrite it so it's nice and neat. Clean it up. So we end up with 4x to the 3rd plus 2x y squared plus, now this term I want to clean this up. I'm going to write it as 2x squared y dy dx minus 2y dy dx equals 0. All right, just like the last example that I gave you, anything containing dy dx, you want that all by itself on one side and everything else on the other. So I'm going to leave these two on the left side, and I'm going to subtract 4x to the 3rd, and I'm going to subtract 2xy squared from both sides. So we get 2x squared y dy dx minus 2y dy dx equals negative 4x to the 3rd minus 2xy squared. Now I am running out of board space. So on the left-hand side, every term contains dy dx, so I'm going to factor that out, and I'm not going to do that in a separate step because I am running out of board space. So we are now going to factor out the dy dx, and you can divide both sides by 2x squared y minus 2y. So our derivative to dy dx is equal to negative 4x to the 3rd minus 2xy squared all over 2x squared y minus 2y. Now I want to clean this answer up. Not that it's wrong, but we can clean it up a little bit. All 4 of these terms are divisible by 2, but because my leading coefficient's negative, I'm actually going to divide all 4 of these by negative 2. So if I divide each one by negative 2, I get 2x to the 3rd plus xy squared all over. Now if I divide each of these by negative 2, this becomes negative and this becomes positive, so I'm going to switch them. So if I divide by negative 2, I get y minus x squared y. You could actually go one step further and factor out an x in the numerator and factor out a y in the denominator, but you don't have to. So here is your derivative using implicit differentiation.